Hey guys, this is Rakesh from Dev Simplified, and today's topic is all about data types. Data types. As the name implies, type of data. Data types represents what type of data which we're going to store in the memory. In Java, the data types can be classified into two types. Number one, primitive. Number two, non-primitive. So what is this primitive, Rakesh? If you ask me the question, the literal meaning of primitive is already existing. So why we need to say the data types of Java as primitive? It's because the data types of Java are being referred or taken from existing programming languages such as C and C++. If you look into the data types of C and C++, you could find almost 32 data types available, say signed integer, unsigned integer, and so on so. But in Java, they have reduced all this into just 8 data types. In that way, they simplified the Java language. Why do we need 8 data types in Java? The answer is very simple, space optimization. Let me explain you the same scenario with respect to simple example. I have a credit card. In order to carry the credit card, I don't need a suitcase or big sharp bags to carry it. My simple wallet is more than enough to carry the credit card. It's like choosing an appropriate and efficient container according to the object which we thought to store. Primitive data types can be classified into numeric and non-numeric. Again, numeric can be classified into integer, in which byte is the least data type which it has. Its size of byte is equal to 1, which shows 2 to the power 8, that is 256. So we need to divide this 256 equally for positive and negative range. So when it comes for negative range, 256 divided by 2 gives 128, so that is minus 128. And I am giving a range for 0, so that the positive sides remains 127. So I can save a value which is in the range of minus 128 to 127. Now I'm going to declare a variable called person1age with a value of 127. It is not showing any error. Next, again, when I go with the value 128, it shows me error because the size of positive range has been exceeded. When I go with person3age with a value of minus 127, it falls inside the range, so it doesn't gives me any error. When it comes to person4age, minus 128. Again, it falls inside the range. But when I go with the value of minus 129, which exceeds the negative value, so it shows me an error. The next data type is short. When it comes for short can save up to 2 bytes of data. When it comes for ranges, that is 2 to the power 2 into 8, that is 2 to the power 16, which represents 65,536. So when I about to divide it equally for positive and negative ranges, I can get a figure of around minus 32,768 value for negative ranges and 0, the remaining 32,767 for positive range. Say you want to store number of days in a year, that is 365. You can choose short. Since byte can store up to 128, so short will be the better option. And the default value of short is 0. So let's see the boundary condition of short. So I'm creating a variable called division with a value 32,767. which is the upper limit. So it is not showing me any error. So when I go with the variable called division1 with the values 32,768, which exceeds the positive range, so it gives me an error. Okay, let's check the negative case. So division 2 equal to minus 32,768. So for this value, it is not going to show me the error because that is a negative range. And when I go with minus 32,769, which exceeds the negative range, so it gives me an error. Size exceeded in the negative range. The next data type is int. So int can hold around 4 bytes of data. So when it goes for data ranges, so we can hold about 2 to the power 32, which is 4,294 billion of numbers. So when I have to divide it equally for positive and negative ranges, so we can find around 2,147 billion of data for negative ranges, and again 0. So for positive range, the remaining 2,147 billion values. So when it comes for int can hold up to 10 digits of data. So let's check the boundary condition of int. So I'm creating a variable called as population with a value which is the upper limit of int. So it doesn't show me any error. When I increase the limit with 1, which exceeds the int's positive range, it gives me an error. Same applicable for negative range as well. Until the negative range value has been exceeded, it never shows us any error. But once the negative range value has been exceeded, immediately it shows as an error as like this. Negative range size has been exceeded. The next data type we're going to see is long. When it comes for long, it can hold a size of almost 8 bytes of data. And when it comes for data range, that is 2 to the power 64, which is almost 20 digit values. So when I split these values equally for positive and negative range, almost 19 digits of data will be applicable on negative and positive side. So you could see you can save up to 19 digits of values in long. Even your Aadhaar card number will be applicable over there, and ISTDs, all these things. And specifically in industries, we basically use long to store time, that is in milliseconds. Let's take the boundary condition of long. I'm going to create a variable called ph with the value which is the upper limit of long. So as expected, it doesn't show me any error. So I'm going to do the same, but I'm going to store a value which exceeds the positive range. Immediately it shows me an error. Similarly, for the negative range, we don't get any error unless the value exceeds the limit. Once the value exceeds the limit, it gives us error. So it says out of range. The long is out of range. When you observe the long variable, you could find a character L which is appended with the long value. The main reason for putting this L over there is it represents long. If you remove the L, it gives you error. Why? Because the compiler considers the value as integer by default. So in order to differentiate the integer from long, we always used to put capital L. It is not mandatory to use capital L always. Even you can use small l as well. But it is hard to differentiate among 1 and L. That's why we are using capital L as per naming conventions. As of now, we have seen all the data types which belongs to integer. So right now what we're going to see is decimal numbers. So floating point. So one of the data type which is present in the floating point is float. Coming towards float has a capacity to hold almost 4 bytes of data and it has default value as 0.0f. When it comes for data ranges, it is very similar to int, but due to the presence of decimal numbers, so float can store more digits than integer. The next data type we're going to see is double. Double is very similar to long. Why? Because it is also holding a space of 8 bytes. Even Oracle recommend us to use float instead of using double to store the values. You can ask me a question like, why I need to use f for floating numbers alone, Rakesh? What is the reason behind it? Say for example, I'm creating a variable called amount, float amount equal to 234.345 f. So this f character is being added along with the floating point to differentiate the floating value from the double values. So the next question arises is, why I need to differentiate float values from double values? Let me explain this concept in a simple scenario. Can we place 64 peoples in a bus which has capacity of 32 seats? Is it possible for them to travel in it? Definitely not. Exactly the same scenario applicable for float and double. Say I'm creating a container which is of 32 bytes of space, whereas when I don't put f in the value, then it becomes 64 bytes. So I could not able to afford 64 bytes in a container which has only 32 bytes of space. So it undergoes precision and causes loss of data actually. So that's why whenever you create a float type of data type, you need to mention f along with the values, stating to the compiler that the value which is being given over here is just 32 bytes of data. So as of now, we have completed float and double in floating point. And now let's move on to non-numeric data types. So that is character. Coming towards char can hold up to 2 bytes of data, which is similar to short data type. So whenever you want to store a character in char data type, you need to specify the character in single quotes. So you can ask me a question, what is the default value of char? It is /u0000, which is nothing but Unicode representation of blank space. So whenever you create a character and you are not initializing it, so by default it will have blank space in it. So let's create a character ch equal to say D. So I'm storing a character D. And when I go with the character div equal to ds, when I place 2 characters at a time, it shows me error, says like invalid character constant. So literally we can say only 1 character at a time. The next data type in non-numeric is Boolean. Coming towards Boolean, Boolean doesn't have any spaces because it can have only two values, namely true or false. So whenever you create a Boolean, by default it will have false as a value in it. Let's create a variable with Boolean data type. Boolean status equal to true. Since true is allowed, so it won't show you any error. Again, let me create another variable called status2 with the value false. Again, it is allowed, so it doesn't give me any error. Say when I try to save any other value such as null as a string, it won't allow. It gives us error. Again, when I try to save a null value, again it shows you error. So we can conclude Boolean data type allows only true or false values. So far, we have completed all the data types which falls under primitive. When we go for non-primitive data type, namely string, array and user-defined classes, we'll be looking over these data types in later sessions. Coming towards keyword learning process, today we have seen almost 8 data types which is equal to 8 keywords. So far we have completed 1 out of 43 and right now it is 9 out of 43.
Subscribe to our channel Dev Simplified and press the bell button for further updates.